So obviously Pythagoras theorem was a really crucial concept in trigonometry. It sort of forms a basis for trigonometry, and you're going to use it in your other years as well. So if you have a look at this simple question here, this is a simple application of the Pythagoras theorem, where we have to calculate the length of AB in this triangle. Now the first thing we need to look at is obviously just confirm that it is a right angle triangle, which we know through this diagram here. We're really sort of figuring out whether we're finding the hypotenuse or we're finding out one of the shorter sides. So we always know the hypotenuse is the side that's opposite the right angle. And in this case, this is what we're trying to find, right? So we can just apply the Pythagoras theorem straight. So we know that AB squared is equal to the sum of the squares of the two shorter sides. So BC squared plus AC squared. So that's 15 squared plus 8 squared. You add that up, you get 289. Then the last step, don't forget the step is you have to take the square root of that to find what AB would be. And in this case, it's just a nice, neat 17 centimeters as a whole number. This is a pretty similar question as well. Nothing too different about this, except that it can be a bit confusing when you see a rectangle instead of a triangle. But they made it easier for us because they've already sort of split that rectangle up into two right angle triangles. And now we're calculating the length of CD, right? So again, we know it's a right angle triangle. However, this time we're already given the hypotenuse, right? We already know the hypotenuse is 17 centimeters. And this time we need to find the lengths of one of the shorter sides. So we need to rearrange the Pythagoras theorem a little bit. Okay, so if you know that AD squared plus CD squared is equal to AC squared, that means that if we take this AD part to the other side of the equation, then we're going to get CD squared is equal to AC squared minus AD squared. And then from there we have all our values. So we know AC is equal to 17. So we've got 17 squared minus AD is equal to 10. So we've got minus 10 squared. So CD squared gives us 189. Again, don't forget the last step of square rooting. If CD is equal to square root of 189, which is equal to 13.75 centimeters, correct to two decimal places. Now we've got a simple word problem. So we've got a ladder that's 6 meters long. It's placed on horizontal ground, resting against a vertical wall. And the instructions for using the ladder say that the bottom of the ladder must not be closer than 1.5 meters from the bottom of the wall. So I guess that's sort of a safety thing. So now it's asking how far up the wall can the ladder reach? And we have to answer in one decimal place. So obviously in questions like this, the first thing we need to draw is a diagram. Okay, so we've got a horizontal ground here. And this is our wall. Okay, and then we've got a ladder that's, sitting somewhere like that. We don't know the exact angle. We don't need to know the exact angle either. Okay, so you can just do a rough drawing like that. Now we know that the actual ladder is 6 meters long, so we know that this is 6 meters. And we also know that the bottom of the ladder must not be closer than 1.5 meters from the bottom of the wall. So if this is the bottom of the wall, and this is the bottom of the ladder, this cannot be closer than 1.5. Okay. So obviously, it can be more than 1.5, but if we have it at more than 1.5, say if you have it here, then we're going to have a lower height that it's going to reach. And the question is asking how far can the ladder reach? What's the maximum it can reach? So that's why we're going to stick to that 1.5 and not pick a number that's higher than that, even though it's possible to. For this question, we want to just find out how far it can reach the maximum height. So we're going to stick with that 1.5 length. Now, as you can see, this is a right angle triangle here. This is our right angle. So this is our hypotenuse. And therefore, we're trying to find this. How far up the wall can the ladder reach? So again, we apply Pythagoras theorem, and we've got x squared plus 1.5 squared is equal to 6 squared. And if you do our rearranging, we'll get x is equal to 5.8 meters, correct to one decimal place. So that means that the ladder can reach up 5.8 meters, provided the fact that if we're listening to the instructions and we are saying that the bottom of the ladder cannot be 1.5 meters closer than the bottom of the wall.